Now let's talk about the effect of inflation upon the interest rates. Okay, and here we have two interest rates: real interest rate and nominal interest rate. Okay, back in chapter 2, when we talk about inflation measurement, all right, or CPI, we already discussed the difference between real and nominal, right? We said real means nominal adjusted for inflation, right? Real means purchasing power, okay? And nominal just means, expressed in current dollars, okay? The current prices. And we even talk about the relationship between nominal and real values. Okay? We said back in chapter 2 that nominal value divided by the real value, this ratio should give us the overall price level. Okay, it could be CPI, could be GDP deflator, or something else. All right, depending upon what nominal and real values we used on the left-hand side of this equation. Okay, if this sounds a little not that familiar to you, but let's check out these two which we discussed before. The first one is we said back in chapter 2 that nominal GDP divided by real GDP equals GDP deflator, right? Again, you should have already done many multiplication. Many calculations about this, right? So again, the real GDP means the real output, okay, and it's calculated on the basis of the base year prices. The nominal GDP is expressed in current dollars, all right? And we also learned back in chapter 2 that nominal wage divided by real wage equals CPI. Okay, so when we talk about the wage negotiation example, between workers and employers, right? Now here, for the interest rate, we just do the same thing, okay? Because we're talking about interest rate, so we're actually looking at the saving behaviors or the saving decisions, okay? Now, suppose we put $1 into a bank account, okay? And a year later, how much we're going to receive back? It's going to be this $1, that's the principal, plus the interest, right? How much interest we could earn, that depends upon the nominal interest rate, right? So here, 1 plus I stands for nominal interest rate, okay? So 1 plus I here, the numerator is the nominal value a year later, all right? And what is the real value? That's 1 plus R. Here, R stands for real interest rate, okay? So the denominator is the real value of our saving a year later. And this ratio tells us 1 plus inflation. Pi here stands for inflation rate, okay? Again, we're basically doing the same thing, okay, as we did before. All right. Now, let's do a little bit more math to help us better understand this relationship. Okay. What are we going to do is we're going to multiply both sides by 1 plus R because we want to get rid of this denominator, right? So on the left-hand side, it's just going to be 1 plus I, the nominal interest rate, which equals 1 plus R times 1 plus pi. All right. And then we're going to open up these two brackets, okay? So what you're going to say is this number 1 times 1, which gives us 1, right? And then 1 times pi, which will be pi. And then R times 1, we're going to get R. And then the last item is R times pi, right? So we're going to get this, all right? Now, to simplify, what we will do is we remove the number 1 because it appears on both sides of the equation, right? So what's left over is nominal interest rate equals inflation plus real interest rate plus real interest rate times inflation. All right. Now here, the last thing we're going to do is we're going to remove the last item here on the right-hand side of the equation. Why? Because this guy, the product, is going to be too small. Now, real interest rate in the United States, for most of the time, it's, just 1 or 2%, okay? And so it's a very small number. And inflation rate, as we already checked it out before, in one of those empirical evidence charts, the inflation rate in the United States is approximately 2%, okay? In other words, here, what we're talking about, this product is 2% times 2%, okay? So you can see how small it is, all right? It's going to be 0.02%, okay? Because it's too small, so we just simply take it out. And eventually, we're going to get this I, nominal interest rate, approximately equals pi plus r. This is so-called the Fischer equation. The Fischer equation. It's named after American economist Stanley Fischer. Okay. All right. The Fischer equation tells us that there's going to be a one-on-one relationship between the inflation and nominal interest rate for a given real rate. Okay, so if R is given, R is a constant, then when inflation goes up by 1 percentage point, the nominal interest rate will go up by the same amount. All right. But what's tricky here is the inflation is not known ahead of time, right? So when we, as the investors, want to make the decision, should we invest on treasury bonds or corporate bonds or stocks, anything else, then we have to compare. So we have to figure out, what is the nominal interest rate, right? The return from purchasing, for example, treasury bonds or putting our money into the bank account, right? But we don't know pi, for example, ahead of time, right? Let's say if you decide, to invest $100,000, okay, at the beginning of next year, 2021, all right? So you have to do this math, but you don't know the inflation rate of 2021, right? Unless you wait till the end of the year when government officially report that, okay? And of course, you have to guess. You have to have an expected inflation, all right? So that's why sometimes when you see this equation, we put pi superscript e here, lowercase letter e, which stands for expectation, okay? So what really matters here is expected inflation, all right? I hope this already reminds you of what we discussed back in chapter 2, especially the Paul Krugman's article I gave you, right? Which is about inflation inertia or self-perpetuating inflation, right? So here, the Fischer equation tells us the same thing, okay? Of course, besides that one-on-one relationship between the expected inflation and nominal interest rate, okay? And it tells us that, the inflation can be self-perpetuating, okay? And or the expected inflation and nominal interest rate are positively correlated, okay? And one more thing I want to bring up to your attention is here, remember, we get rid of this product of real interest rate and inflation because we believe they are too small, right? The product is too small. However, during the hyperinflation period, you would find that the expected inflation is going to be extremely high. So this last item on the right-hand side of the equation could be the most important component, right? most important component of the nominal interest rate. So you cannot get rid of it during an analysis of a hyperinflation. Okay, just be careful. There's no one size that fits all. Okay, we get this simplified version of the Fischer equation for normal periods of time. Okay, when the economy is doing well, when nothing extremely bad happens to the overall price levels. Okay, unless we have to go back and use the complete version of the equation. All right. Now, on the next video, we're gonna start checking out the empirical evidence of the Fischer equation. Okay. As I said before, chapter 5 consists of two equations: quantity equation of money and the Fischer equation. Both are mathematically straightforward, I believe. Okay, and there's nothing really challenging in theory. Okay, but we do pay a lot of attention to empirical evidence to make sure these simple equations hold, or when and where they held in reality.